Let's see if Luis made it in. If he didn't, I have to go remind him to log in. I'll just walk with you guys. Let's go on a little field trip around Flex. If you haven't been in here. Oh, you can't even see anything because I have my background changed. Let me get rid of my background. You can see me walk around. Here we go. Here we are. Going out in the hall. We're walking down here to the library. We're walking into the library and we're saying, hey, Luis, remember to log back in. It's time for science. Okay. There's Luis. There's Miss Anderson. Oh, okay.
I'm actually kind of wondering
Okay,
why.
that's okay.
I have a question.
Yeah, what?
Why is Louise?
Wait, can you show us microbots?
Well, I could, but not right now. But yeah, you know, we were talking about that. We were saying with the Spheros robots, you guys could actually plot things at home and then you could send me your programs and then I could make the robots do it here. So you could do the programming at home and I could make the robot do it, which would be kind of fun. All right, question. Kainoa, what's your question?
Coming to the school today, when where can I get my micro? Do I just
You just come to the door and we'll give you everything. What time are you coming?
after school?
Okay, so like at 3 o'clock. Okay, I'll tell you what, I'll go get everything and I'll leave it at the front for you. Make sure you get your microbit too, okay? Do not
Yeah,
open
that's what I was
microbit.
asking.
So, Eli, hold it up, but everybody see these little packets of microbits? Do not open and play with those. They are breakable. And if you don't know what you're doing, it might not ever work. So please don't play with your microbits. When everyone has them, we will start. It's kind of like when we got our top secret envelope. You don't open them until everybody has them, okay? When you come and get your stuff, you'll get your microbit kit, but don't open it.
Look at me.
I don't know why you have those books, but those look really good. Oh, those are the ones you checked out.
Yep.
All right, friends.
I read most of them.
All right, so it is Tuesday, January 17th, and it's time for science. And in science today, we are going to do, where's Tuesday 17th, 507, the review and the final test. We're gonna do it together because we didn't do all of Mod 5. And so I thought it'd be good if we did the science test together. So everybody right now, make sure you're logged onto Canvas. We're gonna go on and do a quick review, and then we're gonna take the end of unit test all together talking about it. I'm hoping the questions will come up in the same order. Sometimes they do, sometimes they don't. So make sure you're logged on. I'm gonna show.
Wait, is it 7.1?
It's Mod 5. So you're gonna go to Mod 5.
For science?
Oh yeah, science, sorry, not language arts. Science. There we go. Get everybody log on to Canvas. It's Mod 5. And we're going to go here to Mod 5. And we're going to go to the end of it. And there's a review, a quick review. And then there is an assessment. So let's go to the review really quickly. And I'll do that while everybody's getting their Canvas open. So we have been studying about energy. You guys have lots of energy.
Energy and motion?
From light energy to mechanical energy, everything in between. Energy is an essential part of every aspect of our lives. It gives us heat, allows us to see, and we can even store energy to be used later. The more we know about energy, the more we're able to use it in our daily lives. Here we're going to discuss the big ideas and key terms. We are not going to have a discussion with your instructor because, you know, we're not. Here we go. Select each card to flip it over. Mechanical energy. Who thinks they can tell me what mechanical energy is? Anybody? I have to be able to see you guys. Where are you? I want a different view. I guess when I'm sharing the screen, I can't really see you. Anybody have their hand raised? Let me just call on someone. What do you think mechanical energy, an example of that would be, Sasha? Do you have any idea? Mechanical energy. They have a picture of a sailboat right there. I'm hearing nothing. How about you, Amadi? What do you think mechanical energy is?
Like battery?
Like what?
Battery.
Yeah, well, no, not batteries. That's chemical energy. Mechanical energy is like the wind or you pushing something with your body, right? Mechanical energy from the wind causes the sailboat to move. Remember when you blew the wind on your little sailboat? That was mechanical energy. How about heat and light energy? I think you guys know that one. Who can tell me an example of heat or light energy?
Fire.
Fire is a great one. Yep. Or a stove has heat energy.
A light bulb.
Wood, a light bulb. Ooh, sound energy. How about you kids? Give me an example of sound energy right now. Make some sound. And a hush fell over the crowd. Hush. When I say that, you guys have to say hush back. And a hush fell over the crowd. Hush. Okay, sound energy is caused by vibrations. They travel in waves. When they go fast together, then it's a high pitch. And if they go slowly in big waves, then that's a low pitch. Electrical energy, we know, comes from plugging things in. It has to go through something that's a conductor. Chemical energy, they're showing you rust right here. But chemical energy is stored in substances. Rusting is an example of chemical energy. Okay? And here are some terms. Let's see how we do. Match each form of energy with its description. I don't think we're going to do this one because we'll do this on the test. I think we can do this later. Let's practice. How can mechanical energy be transformed into electrical? Using wind or water turbines. Do you guys agree that that would be mechanical changed into electrical? Yeah, it's true. There we go. All right, let's submit it. Correct. All right, we're going on to the next page. We're doing a very quick review. Putting energy to work. No energy can be created or destroyed. It can change from one type to another. It will never disappear or appear out of nowhere. Knowing this and knowing how to recognize different types of energy are the first way that we put energy to work for us. We already use waterfalls to run our computers. What else can we get energy to do? And the big thing we're trying to get energy to do right now is called fusion, where we fuse two molecules together, creates a tremendous amount of energy. If we get it to happen, it'll be clean energy that we can use forever that doesn't destroy our environment. So that would be very cool. We are not doing this Mod 5 discussion-based reflection or rubric or anchor chart. And then we're going to move on to the next lesson. So this is 508, Mod 5 assessment. This is the one we're doing today. It's time to show what you know. Be prepared. Remove distractions, set aside time. All right, so everybody needs to log into 5.08. Oh, that's lovely. How did I get to that? I don't know what I did there. So we're gonna go over here, go to science, because I want you all to
You can scroll down and get the.
we're gonna take the test right now. So we're gonna go to Mod 5, and we're gonna go to the end of it, to the Mod 5 assessment, and go to the one that has the rock. This is where I want you. And I'm not sure if all of our questions are going to be the same.
Can you send me
or
the
not.
link?
No, you have to find it on your computer.
Where is it? Where is it?
Look at it, 5.08. Go to the module, go to science, go to the modules, and go to 5.08.
Multiple 5 quiz.
Has 50 questions. It's a practice quiz. And we're gonna
50
look at
questions.
it.
Yes, 25 questions.
Mine has 50. Yours only has 25. You're in the wrong
No,
one.
that's 50 points.
Oh, you're right. Okay, here we go. Preview. Here we go. This is a preview of the published version of the quiz. So they're going to be the same questions. Can somebody
It's not.
tell me?
It's not in the same order.
Oh, it's not in the same order. Well,
Yeah.
that's sad for me. Let's do it together anyway. We'll do my order, and then when you come to the question, you'll find it. Which of the following has the ability to cause motion?
Wait,
and
what
create
module
change?
is it?
5.08. If you go to, guys, if you go to the calendar and you go to today, it should be on there. The 17th, science. Oh, it's the wrong one, isn't it? 5.07 is on there. What about 5.08? How come it's not on there? Do the tests not show up on here?
Yeah, it doesn't.
I don't think so.
Well, if you go to 507, if you go to 507, all you have to do is go to the next one. So 507 and then you hit next, then you're in 508, right? And then you go to the end of it. Page 1 of 1, mod 5 assessment. Here it is. Where is it? Here, next. Let's see if this works. Okay, there it is. Practice quiz, 50 points.
I found your question. I found the question.
Good, here we go. Which of the following has the ability to cause motion and create change? Energy, space, sound, or mass? What do you think? What have we been studying? Guys, what have we been studying for a month or for a couple weeks?
Energy.
Energy. Question number 2. How is energy causing motion or creating change in this image? We just studied this.
Wait, I have the same question. I have the same question.
Same order, good. So in this case, where's the energy coming from?
The wind to the.
The wind, and it's causing the sailboat to move along the water, just like our foil boats.
Wait,
Question
can you pause real quick?
No,
I lost the module.
I know, but Eli, you'll have to find it. Just listen up if you need to, and then you can take it after. Which of the following is an example of energy causing motion? A bowling ball on a ball stand, is that moving? No. A boy holding a bowling ball, is that moving? No. A rolling ball scattering the bowling pins, is that moving? Yep. The bowling pins after they're hit sitting on the ground, not moving.
Nope.
This one's moving. The rolling ball is moving. Question 4. In a dark hallway, you have a hard time finding your way to the bathroom. To find the bathroom, you try the following: shouting for help, feeling your way down the hall, turning on a lamp, crawling along the floor. Hopefully at night when you're trying to find the bathroom, you don't shout for help.
No.
All 4 are successful, but only one of these options uses 2 forms of energy. Identify the 2 forms. So what do you think? Shouting for help uses sound. That's only one kind. Feeling your way down the hall uses mechanical. That's one kind. Turning on a lamp uses light. And also electrical, right? And sometimes heat. So let's see here. Electrical and light. What do you think? Is that it?
Yeah, sure.
So, I think that's it. Number 5, which interaction occurs when light goes into an object as heat energy? Does it absorb light? Does it make a bright light? Does it reflect light? Or does it refract light? That means bend it. When things get hot, then they've done what?
They have done what?
What has it done if it gets hot? If the sun shines on something and it gets hot, that's because it absorbed the light or soaked it in, right? So this one is absorbed light. Question 6, when you rub sandpaper against a piece of wood, it creates friction. What type of energy does friction produce? Rub your hands together right now and tell me. Is it electrical? Is it light? Is it sound? Or is it
Heat energy.
heat energy? You're right. Number 7. Which property of light is demonstrated in the image? Light has the ability to pass through cardboard. Light passes through all types of objects and surfaces. Light can be reflected off or absorbed by different objects, or light travels in a straight line until it strikes an object or a surface. What do you guys
The
think?
last one.
Yeah, I agree. It's the straight line one. Light travels in a straight line. Which of the following best explains what happens to ice cream when you eat it outside? Ice cream melts because it gives its coolness to the warmer air around it. Remember, which one is energy? Heat or cool?
Heat.
Heat. Ice cream gets cooler because it releases heat energy into the air around it. Does ice cream get cooler? Heat energy moves from the ice cream to the air around it. Ice cream gets warmer because it gains heat energy from the warmer air around it. Which one?
The first one.
Is coolness something you can give, or do you just lose heat? Do you remember our hot water experiment with the microwave, you guys who were here? We experimented with that to see whether whether coolness gives its coolness to something or whether heat gets into cool things. I think it's the last one, because it gets warmer because it gains heat energy from the warmer air around it. It doesn't really give its coolness to anybody. It just loses, it just gains heat. How does sound energy travel? You guys know this one. Is it in circles? Is it on drums? Is it by sound lines? Or is it by sound waves?
Wavy.
Sound wave.
Waves. How do sound waves move? In a straight line, in small circles, up and down, or toward the ground?
Up and down.
Up and down.
Because it's waves.
Because it's waves. Question 11. Which of the following best explains why a drum makes a sound when hit by a stick? Is it because the drum skin vibrates the air? Is it because the drum skin gets hot and heats the air? Is it because the sticks are vibrating when they hit the drum? Or is it because the drum absorbs the sound from the air around it?
The drum skin.
The drum skin vibrates the air.
Exactly. Yes.
Drums have skin.
Yeah, they do. They're
Yeah,
they're often made out of monkey skin, at least in Africa.
What the?
Hannah creates a flow chart about the steps involved in hearing the sound energy produced by vocal cords. Air, put your hand on your vocal cords right now. Air moves past the vocal cords. The vocal cords vibrate. The sound travels into your ears and sound waves are created. Which statement best explains the error in Hannah's flow chart? Do you guys see it?
Yeah.
I don't think the sound waves are created at the end, right? You can't hear them before they're created.
Yeah.
The vocal cords cool down to produce sound energy. That's ridiculous. Sound travels to your ears after the sound waves are created. Yes. The sound waves create the vibrations in the vocal cords. No.
That may travel to your ears after the sound.
I like the last one. The vibrations of the vocal cords produce sound squares, whatever that is. Its sound travels to your ears after the sound waves are created. Which type of material does electricity move and flow through? Producers, conductors, insulators, or energizers? Do you guys remember?
But wait, I didn't hear.
We're talking about things like wire and metal that, and even when we touched each other, that do what to electricity? Do they produce it, conduct it, insulate it, or energize it?
They produce.
No,
No, they don't produce it.
they just help it move, which is called a conductor, guys. They conduct electricity.
They conduct like a heat in frying pans.
And then plastic does not conduct electricity. So if you touch something electric with something plastic, you won't get shocked. Okay.
Really?
How is wind used to produce electrical energy? Fossil fuels, that's like gasoline, are used to power windmills. Is that true, guys?
Yeah. Wait.
No, they're
No, it's not true.
large turbines capture the wind energy. Have you guys seen those big wind machines with those big wings?
Yes.
Those are wind turbines. Those are called turbines. Sailboats create wind or solar panels store wind? No, turbines. So turbines are used in the water. They're like propellers that turn with the water pushing them. They're also used in the air.
Can you slow down? I do not have time to.
I can a little bit, but there are a lot of questions. Sorry. Large turbines capture the wind energy. This is just kind of a review, and it's not great. What type of energy is created by water? Anybody know? Is water used to convert wind energy into electrical energy?
No.
Does water create electricity through rushing water called hydroelectricity?
Yes.
Yes, hydroelectricity, that's what dams have. Hydro means water. Solar panels are used to convert wind into electrical energy? No. Water produces a stronger and faster type of mechanical energy. Well, that one's kind of interesting. Because I think it kind of does, but I think the right answer is this one because I know that that's the answer, but that's kind of a funny last answer. So water makes hydroelectricity. We have a lot of hydroelectricity here in this part of the world because we have big rivers. And the Columbia River is dammed, you guys, about 30 times. It's got 30 dams on it using all that hydroelectricity. The problem is the dams block the entire river. And so the poor fish, do you know how our salmon get to the ocean from way up the river? They take them in trucks around the dam. So they take the baby fish, they put them in trucks and they drive them around the dam. Isn't that crazy? So when you're on the highway, you might be passing some fish.
Wouldn't the fish die though?
Well, it's better than going through the big turbines, which chop them into little tiny fishy pieces.
Oh no.
Nah.
All right, question 16. How does a toaster use electrical energy? Does the toaster turn chemicals into electrical energy? Does your toaster burn chemicals like gasoline?
No. It has never burned chemicals.
The toaster turns light energy into electrical energy? Does it have
Nope.
light?
No. Toaster stores electric energy.
Do you think the toaster stores energy? Is it a
No,
like a
it
battery?
turns energy into light energy.
Okay. Amadi says the toaster turns electrical energy into light and heat.
What? How
Toast-
is a toast
Yes.
if there is no heat energy?
You got to have some heat. Okay, question 17. Which of the following is an example of chemical energy being used?
Eating a sandwich.
You're right. When you eat a sandwich, you're giving your body chemical
What
energy.
about water? What about water?
Well, it doesn't have water on here, does it? Reading a book, I love that. Switching on a fan, turning on the light, no. Eating a sandwich. What form of energy is being used? And did anybody say that to their parents? Did anybody say, thank you for giving me all this chemical energy for dinner?
No.
You got to remember to say that. It's hilarious.
I did.
What'd your parents say?
What do you mean by that?
Did you explain it to them?
No, I just ate after I said that.
What form of energy is being used when fireworks make small explosions? What are in the fireworks?
Chemical energy.
Chemical energy. They're chemicals that burn different colors. We're burning chemicals when we make fireworks. Question 19. Which of the following are examples of chemical energy being released or stored? Number 1, a car battery reacting and releasing energy. Is that chemical energy? A battery?
Battery is
Yes. Chemical, yes. How about a girl eating a sandwich? Is that chemical energy?
Yes.
How about burning propane on your barbecue? Is that chemical
Nope.
energy? Yeah, it
No.
is. Mhm. 1, 2, and 3. They're all examples. Question 20. And I'm sorry I'm going fast, but we only have 5 minutes before the boys' book club. Mixing baking soda with vinegar causes a chemical change. What is the evidence that chemical energy has been released during the process?
I have a question, Miss Laws.
Yeah, who's singing? Please stop singing.
That's
Yeah,
not me.
go ahead.
What is this? There's a homework for 5.7.
The 5.7 was just a review. You don't have to do it. It's okay. I'll
It's-
unassign it. Okay.
Okay,
Don't
thank
worry
you.
about it. Okay. So when you mix baking soda and vinegar, what happens? Does
An
it,
explosion?
the color of the mixture looks white. The baking soda and vinegar disappear. The vinegar and baking soda form a mixture. The temperature changes. Oh, remember we measured the temperature. And there was a temperature change. Remember, it got colder because the heat energy was used up. I remember
Yes.
that experiment. Remember that? I did it,
Yes.
on her counter and it kind of spilled all over. Yeah, I was surprised by that one. Which of the following shows the kinetic form of mechanical energy? So kinetic means movement. Pedaling a bicycle, holding a basketball, lying on the ground, or watching television. Which one shows movement?
Basketball.
Pedaling
No,
a
no, no,
bicycle.
Bicycle. Yes, yes, yes. Which form of energy is used as a roller coaster moves down the track?
Mechanical.
Mechanical. Okay. Not chemical. Which of the following shows how mechanical energy has both stored energy and energy in motion? The energy from food can make us move. The energy from an outlet can toast the bread. The energy from the sun can help grow plants. The energy of water blocked by a dam can turn big turbines. Mechanical energy has both stored and energy in motion. So food is chemical. Outlets are electrical. The sun is light or heat energy. So I think that we have to go to the
Process of elimination is the last
Yeah,
one.
I'm thinking it's the last one. That one was a little tricky. To investigate how mechanical energy affects the number of times a ball will bounce back, Maria dropped a ball from 3 different heights. Which of the following would be a reasonable conclusion? The height from which a ball is dropped does not affect the number of times it bounces. Increasing the height will give the ball more energy and will increase the number of times it bounces. Pretty good. Increasing the height will give the ball less energy? No. Decreasing the height will give the ball more energy. That is a no-brainer. It's number 2. Increasing the height gives it more energy. And the last question, John is designing an experiment to see the effect of mechanical energy on the number of times the ball bounces. Why is it important that John keeps detailed records of his experiment? Hi, Lauren, we're going to do book club. Hi, Lauren, we're doing book club in just a minute. Thanks for coming in. We're just finishing the science test. John is designing an experiment to see the effect of mechanical energy on the number of times a ball bounces. Why is it important that John keeps detailed records? The records show how bouncy the ball is. The evidence produced by the experiment should be replicable. Other people should be able to redo it. The evidence produced by the experiment will prove he's a good scientist, or the records will prove the mechanical energy of the ball will change with height. Which one? Why do you do careful records? It's this one. It's so other people can do the experiment. Let's see how we did. I get a score. I don't think I get a score. Oh yeah, 50 out of 50. Nice. You got 100%. Right?
I want to see.
All right. That is it. If you didn't have time to finish and submit that test, please do it now. In the meantime, I'm going to do the